Wait, can you see my screen now?
Yep, whenever you're ready, we can see it.
Yep, I can see it.
2017 AMC 12.6. Hi, Allan. So the problem, Joy has 30 thin rods, one each of every integer from every integer length from 1 centimeter through 30 centimeters. She places the rods with lengths 3 centimeters, 7 centimeters, and 15 centimeters on a table. She then wants to choose the fourth rod that she can put with these three to form a quadrilateral with positive area. How many of the remaining rods can she choose as the fourth rod? A is 16, B 17, C 18, D 19, or E 20. So the solution. Since the quadrilateral cannot be a straight line, so the fourth side must be longer than 15 minus 3 plus 7, which equals to 5, and shorter than 15 plus 3 plus 7, which is the max, and it's 25. And this means that Joy can use the 19 possible integer rods lengths that are in between 6 and 24. However, since she has already used the rods of length 7 centimeters and 15 centimeters, the answer is 19 minus 7, which is 17. So the answer is B.
Good job.
And
all right, here you go. Here's the question. So let G of X be a polynomial with a leading coefficient of 1, whose three roots are the reciprocals of the three roots of f of x, which is x to the power of 3 plus ax to the power of 2 plus bx plus c, where 1 is less than a, which is less than b, which is less than c. So what is G1 in terms of a, b, and c? So what do we have? So we have x to the power of 3 plus ax squared plus bx plus c. So we're going to assume the roots of this are p, q, and r, because three roots. And so the roots can be written out like this. And actually, the three roots, let me pull up the theorem for you. So we have the discussion board. And so polynomial. So in a polynomial, an x n and an minus 1 and times x to the power of n minus 1, and it could be expressed in the form an times x minus r times x minus r2, where r1, r2, and r3 all the way to rn are the roots of the polynomial. So here's an example: x to the power of 2 minus 1. It has roots.
What are you doing?
Pardon? Can you mute yourself if you're not talking to me?
What? What?
All right, forget it. If you're not gonna, just remember to mute yourself. So x to the power of 2 minus 1 has the roots -1 and 1. So x to the power of 2 minus 1 can be expressed as x minus 1 times x plus 1. So here we have the representation of a monic polynomial in terms of roots. So in a polynomial where the leading coefficient is 1, which is our case right now, it can be expressed in the form of x minus r1 times x minus r2 all the way to x minus rn, and r1, r2, r3, rn are the roots of the polynomial. And so this is the exact same as this one up here, except it just doesn't have the an in the front because an is 1 and multiplying anything by 1 is just itself. So we don't need to include an there. So we write it in this form. And if we go ahead and expand this, we go ahead and expand this form. We multiply the x's and we multiply the x with the q, and this is standard expansion. So we get eventually we get x to the power of 3 minus r plus q plus p times x to the power of 2 plus q times r plus p times r plus p plus q, x minus p times q times r. So what do we get from this? If we compare this with this, we get that this part is A, this part is B, and the last part is C. So what do we have? A equals negative R plus Q plus P. B is Q times R plus P times R plus P times Q. And C is just negative P times Q times R. All right, so we have that. Now we're going to move on to here. So we have the information of f of x now. So now we need the 3 roots of gx. And if you remember the question, it's asking what is g1, and it's g1. G of x's roots are the reciprocals of the 3 roots of f of x. And if you're not familiar with what that means, it's just the inverse of something. It's basically just dividing, just having it as the, it's basically the equivalent of doing the power of -1 to it, which is equivalent of 1 over whatever you have. So in our case, we had f of x, the roots were p, q, and r. So the inverse of those is 1 over p, 1 over q, and 1 over r. So g of x, so the roots are x minus 1 over p, x minus 1 over q, and x minus 1 over r. So it's basically the same thing. It's just, you just have the inverse of r, q, and p instead of just r, q, and p. So once we finish with this, the A, B, and C are pretty much the same. It's just the inverse. So A prime is negative, it's negative 1 over r plus 1 over q plus 1 over p, and B prime is 1 over qr plus 1 over pr plus 1 over pq. And C prime is 1 over negative pqr, or negative 1 over pqr. So, all right, so we have information about the information that we need about both of those now. So both functions, we can now figure out what g1 is, g of 1. So here is the function for g of x. So that is the same. All we need to do now is figure out g of 1. So if we plug in 1 in replacement of x, we replace the x with 1, whatever x shows up. And here we don't really need to include the x after. We don't need to include the x here and here because it's multiplying by 1. So that doesn't really do anything. So we can just exclude that. And here we can change everything, the denominator. We actually change it to a negative. You'll see why in a second. But if we flip that, we have PQR over PQ, negative PQR over negative PQR. This is the same as just 1 if you divide it by itself. And if we if we can flip this to a negative sign, if we flip the negative sign here to a plus sign, it's the same thing. Adding negative is the same thing as subtracting. And here, this is also the same thing still. It's just flip the signs. And so we have the same thing essentially. It's just replaced x with 1. And if we look back now, we can actually figure out what, remember what each of these means. So we can go back and look what A, B, and C were, and we can match those up. So that is really helpful. So we can see A equals negative R plus Q plus P. Let's check for that. All right, right here, we have A right here. This one right here is A. So we have that. And if we check for B, we have QR plus PR plus PQ. So let's check if we have that. That right there is B. So we have B over here. And C is negative PQR. So let's check if we have C. Yep, we have C right here. So this is C. And this is also C. And all the denominators are C. So we can go ahead and add these up now. We needed the denominator to be the same because if we were going to add, we need a common multiple. So we need all of them to be negative PQR. So if we go ahead and add those up now, basic fractions, we have A plus B plus C plus 1. So this is now our final answer of this problem. So you can come here and check for, yeah, if anyone, yeah, it should be this one right here, A. So 1 plus A plus B plus C divided by C. So that is the answer for this one. And now we have the second question. So I'm gonna submit that. So next question, we have the final question. And I'm gonna open up this one. So we have a question. So this is the final question of our test. So this is let Q of Z and R of Z be unique polynomials such that Z to the power of 2021 plus 1 equals Z to the power of 2 plus Z plus 1 times Q of Z plus R of Z. And the degree of R is less than 2. So that means R is less than a quadratic function. It's not quadratic, it's linear and possibly constant. So what is R of Z? So this, we have this. So the first thing we do is we can try dividing. We can try finding the remainder of we can try finding the remainder for these two, the quotient and this Z squared plus Z plus 1. And then the remainder is R and Q is the quotient. So again, we have the degree of R is less than 2. And so r is linear or constant. So we if we try dividing, we get this pattern of z of 2019 minus z of 2018 plus z of 2016 minus z of 2015. So it's like sort of a positive, negative, positive, negative. And if you're not familiar with synthetic division, we'll cover that next time. But it's similar to long division. It's basically, yeah, long division. And so we just, if we divide this into this, you can see it's a very, it's a bit hard to figure out what the final remainder will be, since there are so many terms still. So what we can do instead is we can come here and we can actually take a we can take a multiple of the original, and we can divide with the multiple of the original instead. So we can take a multiple of z to the power of 2 plus z plus 1, which since that has too many terms and we want something with just a simple 2 terms or 1 term, which is easiest to use. So z to the power of 3 minus 1 happens to be a easy multiple to use with 2 terms. If this is also a multiple of z to the power of 2 plus z plus 1. So we can divide that by z to the power of 2021 plus 1. And this time we get a nice and easy pattern to work with. This the power decreases by 3 each time. And you can figure this out easily now. So you have z to the power of 2018. We could just figure out how many times or what the remainder of 3 over divided by 2018 is. And if you do the simple long division for that, it's just 2. The remainder is 2. So then now we know that the final power of this division is, the remainder is going to be 2 to the power z to the power of 2. And since you can also see there's a, every single time we divide, there's a plus 1. So we know that's also going to be with the z to the power of 2. So we know our final term is going to be z to the power of 2, and our remainder is going to be z to the power of 2 plus 1. So now we have the remainder of the multiple of z to the power of 2 plus z plus 1. We can go ahead and divide the remainder of the multiple by the original expression to now get the final remainder. And you can do this because it works. You can try it yourself. Let's take, for example, 15. And let's say you want to find the remainder of, what 15 divided by 2 is. But let's say that it's too big. It's hard to do that. So you can find a multiple of 2. So let's take 6. So that is 3, right? So we can now divide the remainder of the multiple with the original. So we can now do 3 divided by 2, and the remainder of that is 1, right? So it's the same as dividing 15 by 2 outright. So we can do that. It's easier to work with also. So right here, we do that. So if we take our remainder here, z to the power of 2 plus 1, and divide it by, divide, we get, it's a really simple and quick division process because they're really similar at this point, and we get negative z. So negative z plus 0 is negative z still. So negative z, and that is basically our final answer. Our final answer is negative z. So let's come to this question. So the final answer for this one is also A, so negative z. So does anyone have any questions?